Where our facility is located, which is about 30 minutes from the Limerick nuclear facility, and we pour in the off-peak hours at night, utilizing this nuclear power. So we're pretty proud to say that our carbon footprint is very little, if not any, because we're using strictly nuclear power and we're off the grid. What we're watching now is actually one of the molds being dumped. This is the aluminum casting that was just poured about 20 minutes ago. You can see the Bishop's Crook capitals in there. These are the decorative elements under about midway up the pole. As the smoke clears, you can see the decorative casting in its raw form. You also see the yellow portion there. That's the core that makes the casting hollow, and that'll be when it takes down to one of the stations, what we call shakeout. They'll remove the sand off of it, break out the core with either a jackhammer or a vibrating rod that goes up inside the casting to break that sand core out. You can see the gating that where the casting or the non-decorative portion of it that's off the side, that's the gating where it was poured into the mold. You can see the decorative element again. Again, Spring City's noted for its detail and ornamentation, and the Bishop's Crook setup is really a good example of how much detail we can get into it. And you can see too how quickly aluminum solidifies. We poured these about no more than 20 minutes ago, and they're still hot, probably around 600-700 degrees, but they're at its solid state, and they'll be cooled to the touch probably in the next 30 minutes to an hour. Right now you're taking a look at one of the bowls that's going to be transporting the liquid ductile iron to the molding station. It's being preheated by a torch, and you can see obviously the intense heat that's being displayed onto the bowl. It's about, right now, a little over 1,000+ degrees, maybe even hotter. But the metal that's going to be getting in there is going to be close to 2,800 degrees. And keeping this bowl at a high temperature minimizes any decrease in temperature while we're transporting the metal to the floor. The bowls that you're looking at are made of first of all, it's a cast iron and steel bowl that's lined with a special liner that can take heat, intense heat of well over 3,000 degrees. The metal that's going in obviously is around 2,800 degrees, so there's no way that the bowl will fail because of the intense heat from the metal that's inside it, because it can withstand the heat of the 2,800 degrees ductile iron. So we're taking the hopper over the induction furnace and about ready to implement the first charge of the night. We're dropping the iron ingot into the furnace, and you're going to see a nice little fire explosion. There's some of the scrap metal that was just dropped into the furnace. Some of that is the old gating and risers, crushed engine block, and of course iron ingot. These furnaces were preheated for about the last hour or so. And again, with an induction furnace, it's a magnetic field that charges the metal inside and creates a energized field that heats and melts the metal instantly. Tonight's pour, again, is going to get up to about 2,800 degrees because we are pouring ductile iron. It's closing the top of the furnace to retain the heat and intensify the heat inside the furnace. In my hand right now is some magnesium ferrosilicate, and this mineral is placed inside the bowl. And as the liquid iron is being poured into the bowl, you're gonna see a white flash and almost sparkles come out of the bowl. And this is what helps manipulate the iron and treat the iron to get to its ductile rating of about 65,000 yield. Now he's scraping off some of the impurities that rise to the top. We'll call it fluxing. And right now, he's pouring in the magnesium ferrosilicate that you saw earlier in my hand, and that's going to help treat the metal to get it to its ductile rate. Again, loading some more of the magnesium ferrosilicate. He's going to put it in the other bowl. These Bishop Crook poles are so large that we pour 2 bowls simultaneously. One of the guys just put a cover on top of one of the bowls. That's to keep the heat from the preheated bowls, the heat inside the bowl, so that the iron has a lesser chance of cooling as it's being transported from the furnace to the floor. Again, there's the white flash from the magnesium ferrosilicate and the iron being treated to get to the ductile rating of 65,000 yield. Liquid iron pours with the viscosity of like motor oil and like molasses. It pours really slow. So your wall thicknesses are usually 3/8 to 1/2 of an inch, that void that we see between the core and the pattern. Now we're taking the bowl out to the floor. Here comes the second bowl with the liquid ductile iron. And he's going to set up at the other side of the pole where the other gate is, and they're going to pour simultaneously, as we talked earlier when we were watching the metal being poured into the bowl. Now they're pouring the ductile iron into the Bishop's Crook mold. And they want to remain pretty consistent at both ends as the iron moves through the mold. Now it's an extremely volatile process. You can see those C-clamps and wedges, that's holding the mold together because the iron rushing through there wants to push that air out, and of course all the gases that are being emitted from the core, it wants to get out. These molds would take about 2 to 3 hours to cool. And then what'll happen is later in the evening, as these are cooled, they'll dump these flasks over, take the castings over to what we call shakeout, kind of what you saw with the smaller castings, the aluminum castings that were dumped over. They'll clear this floor and have the empty flasks ready for the molders in the morning to repeat the whole process over again. Typically, our product takes 8 to 10 weeks to manufacture from start to finish. Right now, we're in the beginnings of the finishing department, and what you're looking at are the poles that were cast last night. You can see still the baked on sand, a lot of the gates and risers, the chaplets, all of these will be taken off. But this is when the pole starts to become what it is, this beautiful decorative element going from start to finish. Now after these poles sit and cool, they're taken over to the blast room. And we utilize steel shot and grit. And the worker will come in here in his protective suit and shoot these poles with a blast gun, which you can see takes it down to bare metal from the grit and the steel shot. So all the baked sand and any of the impurities that were left on the casting are removed. We're still in the finishing department, and what you're looking at right now are some of the Washington twin cross arms. It's actually upside down. You see these areas here. This is where the fixtures slide on. It's a twin cross arm, so 2 luminaires go on top of it. But you can see the decorative element, and the arm is starting to come into its own of what, you know, showing the detail, grinding off any of the harsh flashings or debris that's on the casting when we pull it out of the mold. What you're looking at here is, again, some more of the hard finishing, getting off some of the chaplets, cleaning off any of the debris that's, again, been cast into the pole. This is a standard process. And again, the poles and the shafts are starting to come into the finished product. This particular gentleman is grinding a 2-piece number 16 pole that we utilize in the city of Washington, D.C. This is a column that rotor-locks into one of the bases that, as we walk by, we'll probably see one, and that goes into the top of the base and is permanently locked into the cast base. Again, more finishing department. These are small fixture casings for the city of Philadelphia. Some hinges for some luminaires. This particular gentleman is grinding one of the cast electrical junction boxes I talked about. These boxes are placed into the ground or below bridges and utilized for pull boxes or to house transitional electrical connections on bridges, streetways. Still a formidable business for Spring City, and we've actually seen a resurgence in it because of the cast iron. It's so durable and lasts so much longer than any of the composite boxes or cement boxes that are used over the last 10 to 15 years. What we're witnessing right now is Jake Bray, an employee who's been here for almost 10 plus years, is what's called a swing grinder. And he's taking this heavy grinder and grinding off those chaplets that you see, those little portions of casting sticking up outside of the shaft. Those are what's supporting the core. Parts of them are still sticking out, and he's grinding them off in any of the other rough finishes. This is probably the one portion of grinding that's the most rough on the pole, removing all of the excessive gating or castings and chaplets that are sticking out of the shaft. What you see here is a gentleman doing some of the fine sanding on one of the Washington poles we talked about that had been casted this morning. You'll notice too on the casting itself, these particular poles are going to a project in Tennessee called Duck River Walk. And you'll see a square up top here and some embossings on the casting. That's for a GFI receptacle. And one of the things, because we're a foundry and our custom capabilities allow us to, is to cast this embossment into the pole so that we're not mechanically attaching anything, nor are we doing any welding. So this is actually cast into the pole. and not other manufacturers really can't or don't have those capabilities because they're not doing the actual foundry.